Hi, this is MD Shabana Sultana, working as Associate Professor in the Chevron Engineering College, Chevron. Today, I want to discuss about the liquid crystal. In the last session or in the last lecture, I explained about the fullerenes, its preparations, properties, and the types of fullerenes. Today, I'm going to tell about the liquid crystal interaction and the types of liquid crystals and the applications of the liquid crystals as well as the properties also. So what is a liquid crystal? Liquid crystal are the matter in the state that has the property between those of the conventional liquid and those of the solid crystal. That means it is a state that occur between the solid and the liquid. It possesses the property of both the liquid and the solid, crystalline solid, and it also possesses the properties which are not found in either of the liquid or the solid. That means it differs from the liquid, that they are still some orientational order possessed by the molecule. And this liquid crystal, it have many different types of the different phases which can be distinguished by their optical properties. And it can be found naturally and in the technological applications. Many proteins, cell molecules, and tobacco virus are the natural liquid crystals. Most contemporary electronic displays, solutions of the soap, and various related detergents are synthetic liquid crystals. Coming to the discovery of the liquid crystal behavior was first observed by Friedrich Brenner at the Charles University. Pregain derivatives of cholesterol, which now belongs to cholesteric liquid crystals. The name liquid crystal was coined by Otto Lehmann in 1904. Later, liquid crystal becomes a topic of research into the development of flat panel electronic displays to replace the cathode ray vacuum tube in televisions from 1962 onwards. Coming to the orientational order of the liquid crystal, assuming that the direction of the preferred orientation of in a liquid crystal is in the upward direction, this direction can be represented by an arrow called the director of the liquid crystal. What is the criteria for a molecule to become a liquid crystal? The molecule must be elongated in the shape length, and it should be significantly greater than its diameter or width. Molecule must have some rigidity. Suppose if we consider it is a molecule of the liquid crystal, it is having some sort of rigidity in its center region, and the end of the molecule must be somewhat flexible. So this is the main criteria for the molecule to behave like a liquid crystal. Coming to the types of liquid crystal. Liquid crystal can be attained either by the action of the heat or by the action of the solvent on amphiphilic system. Amphiphilic means both hydrophilic and hydrophobic system is present in one system. It is known as the amphiphilic system. And this liquid crystal can be classified into three types. Mainly two types. Another type is also there, which I'll explain. The first one is the lyotropic liquid crystal. Liquid crystal exhibit a phase transition into liquid crystal form when both the temperature and the concentration of the liquid crystal molecule in solvent changes. That means liquid crystal phase is formed by dissolving the compound in an appropriate solvents, which is under the given concentration and the temperature conditions, is known as lyotropic liquid crystals. Coming to the second type of liquid crystal, which is known as the thermotropic liquid crystal. Before going to the type of the thermotropic liquid crystal, I want to discuss the another type of liquid crystal, which is known as metallotropic liquid crystal, which are constituted by both the organic and inorganic molecules. They exhibit the phase transition into liquid crystal phase when temperature, concentration, and organic and inorganic composition ratio changes. Coming to the third type of liquid crystal, which is known as a thermotropic liquid crystal. In this, the liquid crystal phase is obtained by changing the temperature. And it is classified into three types. That means, if the temperature is too high, thermal motion may destroy the ordering of liquid crystal phase, pushing the material into conventional isotropic liquid crystal. The following are some of the phases as the temperature is changed. The liquid crystalline phase of the thermotropic liquid crystals can be observed by carefully lowering or raising the temperature of liquids and solids respectively. Thermotropic liquid crystals are formed from organic molecules like rod-like shape, rigid and planar ring structures. And this thermotropic liquid crystals are further classified into three types. They are pneumatic phase, smectic phase, and the third one is the cholesteric phase. Coming to the first one, that is a pneumatic phase. Pneumatic in the Greek means, that is, it is derived from the Greek word known as pneuma, means thread-like structure. The pneumatic liquid crystals are less ordered. They pointed in the same direction, characterized with a total loss of positional order and near normal flow behavior similar to the liquid phase, with simple structures. That means in the pneumatic phase, the molecule have the same direction in the space, but change in the orientational order. That means the arrangement of the molecule, the position order is changed. Coming to the second type of thermotropic liquid crystal, known as smectic phase. In the Greek, smectic means soap. The substance that form a smectic phase are soap-like. In the smectic liquid crystal, there are small amount of orientational as well as positional order. The molecule form plane perpendicular to the axis of the molecule and it tends to point along the director. That means the molecules are arranged in the layers or a plane. They show general structural order in the nematic. And this smectic phase, they are again of three types based on the orientation of the director. Orientation of the director, they are again of three types. They are smectic A, smectic B, and smectic C. Coming to the first type, which is known as the smectic A, see here is a diagram of the smectic A. In the smectic A, the long axis of the molecule are parallel to the preferred direction, which may be normal to the plane. That means they are arranged in the form of layers in which the molecules are arranged or they are parallel in the direction, and the orientation of the molecules are disturbed in the plane. Whereas the smectic B, the direction is perpendicular to the smectic plane, with a molecule arranging themselves into a network of hexagons within the layer. Smectic C, the long axis of the molecule are disordered and parallel to a preferred direction, which may be tilted by a certain angle. That means it creates some certain angle between the two molecules. That angle is known as a tilted angle. That means in the mesophase, the molecules are oriented as the same order as that of the smectic A and B, but in the smectic C, it is having a tilted angle between the molecular arrangement and the surface of the layer. And the phase is measured by the rotation of the angle. So these are the smectic liquid crystal. Coming to the third type of phase, which is known as the cholesteric phase or cholesteric liquid crystal. The name of this liquid crystal originated from the fact that many derivatives of cholesterol from this structure and the molecules are chiral. Chiral means it's having different shapes in one layer, which does not match from one to another. The structure of these crystals are similar to pneumatic liquid crystal, but each plane of the molecule is twisted slightly in relation to the plane above and below. The molecules are aligned parallel to a preferred direction as in the nematic phase. When proceeding in a direction normal to the plane, the preferred direction rotates continuously. The result is helical structure. Like the nematic phase, the molecule in this phase are also parallel to each other within the layer. The director axis changes regularly in the nature to form a helical structure. This regular change is called pitch. The pitch changes with the temperature and by the boundary conditions. The best example for is cholesterol benzoate and hydroxypropyl cellulose. Next, coming to the Applications of the liquid crystals. Liquid crystal find a wide use in the liquid crystal display, which is known as LCDs, which rely on optical property of certain liquid crystal substance in presence and absence of electric field. A typical device, liquid crystal layer, sits between two polarizers and that are crossed, that is oriented at the angle of 90 degrees to one another. Thermotropic chiral liquid crystal vary their pitch with changing temperature as a result of color of the material changes as the temperature changes. They are used in the thermometers, for aquarium, swimming pools, and infant baths, and also to look for hot spots for failure analysis in semiconducting industry. And liquid crystal lasers are used in casing the medium for stable monochromatic emission. When the temperature of cholesteric liquid crystal is changed over a particular range, these liquid crystals exhibit color change from red to violet. This important property is utilized in thermography, that means for measuring the surface temperature, to indicate the temperature variation by using color differences for following thermal diffusion, thermal mapping, like integrated circuits and aerodynamic testings. And most of the liquid crystals are used in the helmets and bulletproof vest and is used in the battery testing strips. And it is also used in the radiations and the sensors. It is used in the switchable light panels for the windows and optical memories. And used as a solvent in the NMR reactions, etc. It is also having the medical applications of the liquid crystal for studying the circulatory system, detection of tumors, skin, and breast cancer. Liquid crystals are also used in finding the efficiency of heat engines and testing of radiations. So this is about the brief introduction of the liquid crystals, types of the liquid crystals, and applications of the liquid crystals. And in the next lecture, I'll discuss about the superconductors. Thank you.